hell? Uh-oh. One second.
'Why am I the only one in this meeting right now? Where is everybody?
I am here. I'm not sure everyone else is.
I can't see anybody. That's so weird. I can't even see you.
Well, my webcam died earlier today. It worked for my first meeting of the day and then didn't work for my second. So that's probably why you can't see me.
I was so confused. It said like the waiting room, and then I saw that you let me in. I'm like, wait, like I can't see you at all. I was very confused.
Yeah, I think people are slowly coming now, though.
Oh, okay. I was very confused for a minute there.
Yeah. Oh, it is 6. Well, let's give people another couple minutes to join in. And I was saying just a minute ago that my webcam died this morning, so that's why you can't see me. So sorry about that. I'm getting a new one, but it won't be here immediately. So
That's okay.
Hey, Lindsay.
Hey, how are you?
Good. How are you?
Really tired. It feels like
Staring at
11
my computer
o'clock.
all day.
I know. It's awful. I appreciate you doing this though, Dr. McKibben.
oh
Me
yeah,
too.
sure.
I wanted to ask you about the homework solutions. I didn't see them on D2L yet.
No, I am still polishing those off, and I actually have a question for everybody, or for everybody who shows today, I guess, about those. So
Okay.
let me just hang for a minute or two, and then let me ask you.
Okay.
And our
thanks.
next homework isn't due until after Thanksgiving, right?
That's right.
Awesome.
Yeah.
Are we allowed to use a crib sheet for this exam as well?
Yes, same rules. Yeah.
Cool.
Yeah, so I'll just review the rules and I can review it again if others show. But yeah, so you're allowed a note sheet for part 1. Part 2 is open book, open note. Yeah, and part 1 is more kind of like last time, it's more theoretical, more conceptual. and part 2 is more the SPSS. But you could, I guess, technically have to interpret SPSS output for part 1. Do you guys know if anyone else is planning to arrive? I know someone said that they weren't coming.
I am not aware of if people are planning on coming or not.
Okay, all right. You know
That
what?
probably was not helpful at all, but
No, that's fine. So let me ask my question, and then let's get into starting the review and going over whatever you want to talk about. So here's my question. Was it, in terms of the homework solutions, I know you want to see, of course, the output. Is the write-up also an important piece that you want to see, or do you feel like that's more of an easy part? And feel free to say both.
I was gonna say it's kind of both for me. I think
Okay.
sometimes the write-ups are easy for me, and then some other ones are like harder for me. So
Okay.
definitely, I think seeing the write-up is helpful.
Is helpful. Okay, that's fine. I just wanted to check in. Okay. I will, oh, sorry, Lindsay, do you have something you want to add?
Yeah, I was just gonna say I agree. I think that for me, like the write up is like sometimes I get caught up with that, so I would like to see it if that's
You'd like
okay.
to see it. Okay. Yeah, no, that's no problem. What I'll probably do to try and I just really want to get this to you like tonight if possible, because I know the exam's Wednesday. Maybe what I'll do is at least give you one write-up of each kind. And we'll see what I have time for. I mean, I'll do as much as I can, and then I can keep going, but at least I'll get you as much as I can tonight and then keep going with it, I guess. So that you'll have the benefit of both. Okay. Questions. What questions do you have for me about the exam, about concepts, about any of it?
All of it.
All of it. Something more specific might be helpful. Give me a place to start.
So I guess this test starts with ANOVA, right?
Right.
Okay.
Like, do you want to go through like the one thing I could do is like, and this is more of a part 2 thing, but what I could do is kind of go through like, how do you make the decisions between the different tests?
Yeah, I think that would be helpful.
Okay, let's do that. Let's start there anyway. Okay. So in terms of when you're first looking at the problem, I guess the first thing you have to figure out is what test you're going to attempt, right? So if you've got groups, then it's got to be either the one-way ANOVA or the repeated measures ANOVA. Because we talked about the factorial, but it's not going to be like we didn't talk about how to run one. So it's got to be, if it's groups, it's got to be either, and then we'll talk from there if it's, the proper ANOVA or the Kruskal-Wallis or the repeated or the Friedman. But if it's got groups, it's got to be some kind of ANOVA. Now, if it's 3 or more independent groups, people prefer blue, people prefer green, people prefer red. Then it's the one-way ANOVA. If it's 3 different time periods or more, then it's the repeated measures ANOVA. So if we're looking for differences, and we're trying to look at differences either across groups or over time, then it's either the one-way ANOVA or repeated measures ANOVA, respectively. If we're looking to understand relationships, associations, then it's either correlation or simple linear regression. And I'm sorry, for simple linear, it won't even be part 2 thing, right? Because that could just be a part 1. That's not going to be, we didn't get that far. So then you've got some kind of correlation if it's an association. What I was going to say, and this will be helpful to you going forward, is if it said association or relationship, it's a correlation. If it had said prediction, it's a simple linear regression. And I guess that's a helpful hint for part 1 anyway. So that does have its utility now. Because regression is all about prediction. So I think that's a worthwhile point. Okay. So that's how we start, I guess. That's how we start knowing where we're at. And then from there, we have to boil down and figure out, okay, I'm looking for a difference between groups. Is it a one-way ANOVA or a Kruskal-Wallis? And to see that, what are we looking for with one-way ANOVA? We're looking at outliers, and we're looking at normality in each of our groups. If we've got both of those, we're going to chug down the one-way ANOVA trail. If we're missing either, if we have either outliers or lack of normality, then we're going to go with the Kruskal-Wallis. Now, there's one more potential offshoot with the one-way ANOVA, if you remember, and that's whether or not we know we're on the one-way ANOVA path, but are we going to do the standard one-way ANOVA or the Welch? And the difference there is whether or not we meet the criteria for homogeneity of variance. If we meet the criteria for homogeneity of variance, in other words, homogeneity of variance is not significant, it's not less than 0.05, then we're doing the standard one-way ANOVA. Otherwise, we're into the Welch. Okay. With the repeated measures ANOVA, and I'm almost tempted to, let me go ahead and do that. With the repeated measures ANOVA, what we're looking at is between that or the Friedman, right? And for this one, we've got to know whether or not we have outliers once again, and whether we have normality across time periods. So similar explorer procedure with a slightly different goal. Still about normality, still about outliers. Right? And if we meet those criteria, then great, we're doing the repeated measures ANOVA. If we miss either of those criteria, then we're off to the Friedman. And then let me show you this. I'm going to switch my share, maybe, if I can. I want to go over to, so I think the repeated measures ANOVA, here it is a little bit like one of the more complex ones in terms of, how do you actually, the little pieces in there. It has its own little pieces. So when you go into the repeated measures ANOVA and you run that, here we're looking for the sphericity one, right? That's the thing we've got to meet here.
Are you able to go over like an example of sphericity? I feel like I really struggle with this one.
Yeah. Let me, oh, I meant to switch my share, but I haven't yet. Hang on. It's got to be here. 1 second. Why won't you show up? I guess I'll go here. Oh, here it is. Okay. Perfect. Okay. So yeah, let's look at this with Laird and look at some results so you can actually see. Do you mean what it means or how to see it?
How to see it.
Okay. Okay, yeah, that's cool. Where is, one second, here it is. Testing for the assumption of sphericity. It's right in here. Launchley's W. We're looking at this sig value. You're able to see my cursor, right? I assume at least you can. Okay.
So it's like the normal thing of like if it's less than 0.05, it's significant.
Yeah. You just got to find the Launchley's W, because it's Launchley's test of sphericity technically, and then go across to the sig value. So that's all you need for telling whether or not you've got a sphericity problem or not. So in this case, we have a problem. I want to show you the rest though. Okay, and then these are the geyser greenhouse, and we're going to go with I always call it geyser greenhouse geyser correction. So we have that, and then I don't want to show you sphericity assumed. I want to show you when it's not assumed. Well, I'll show you this. It's just as good. If you have the sphericity, then you're reporting the top set of numbers. If you don't have the sphericity, you're reporting the greenhouse geyser set of numbers. And if you remember the top, this is all like the SS between, if you will, and this is the SS within, the SS error. This is the DF between and the DF error, the mean square between, the mean square error, our F and our sig value, and our partial eta squared. So you'll notice, again, there's not really a huge difference. I mean, look at all these F values. They're like they are identical, right? And the P values are almost all identical. So it usually doesn't make a huge difference, but to get it right, you want to report the appropriate one. Does that clear up the sphericity thing?
Yeah, so do we report any of like that error stuff or no?
I don't think that let's look at the reporting actually. Because what I asked you to do for this is to go ahead and follow Laird pretty closely.
Right.
So let's just look at Laird. And yeah, they seem to, oh no, that's just a partial eta squared. That's their version. They did a different thing. So I don't think it's critical. I mean, I was going to look here to see if they did it anyway, but I don't think it's, I'm going to say, let's look at this one where it's violated, but yeah, they give the epsilon here. I don't think it's a critical piece. So I'm going to go ahead and say you don't need to do that. Just go ahead and report the appropriate ANOVA when you're reporting. So if you would like to, you can leave this line. Epsilon was 0.648 is calculated according to Greenhouse and Geyser in 1959 and was used to correct the one-way repeated ANOVA. You don't need that sentence if you don't want it. Okay. The other important thing about ANOVAs, and this goes for all ANOVAs, is that if you recall, while there are ways to actually go ahead and do custom contrasts and all that kind of stuff, we didn't get into that for this class. So we are considering all of our ANOVAs two-tailed. So we're never dividing the P by 2 or the sig value by 2. We are always treating this as a two-tailed thing. So, which is not to say if you have a dissertation and you're using an ANOVA, you can't come up with custom contrasts and then take advantage of one-tailed. You can, but again, just for this class, we're just treating everything as two-tailed when we're doing the ANOVAs.
So So even if like the like example you give us, or like the like paragraph, whatever you give us is like, it seems like it would be one-tailed, should we just make it two-tailed?
Just treat it as two-tailed. I would aim not to give you such a paragraph on a test. But if by some crazy chance I did something like that, go ahead and treat it as two-tailed.
Okay, perfect.
Yeah. So that's the basic stuff with reporting and going through the scarcity assumption for one-way repeated measures ANOVA. If you went to Friedman, and I guess I'll just say, if you go to Friedman or Kruskal-Wallis, you can pretty much follow what they've got under Laird for your reporting write-up, but do make sure you've talked about the assumptions. Do make sure you've said, it was decided to run a Kruskal-Wallis H-test because, so due to the fact that normality was violated, and, give that information. That's the one thing that Laird sometimes leaves out that you should go ahead and include. Okay. So that's true for the Kruskal-Wallis, and that's true for the Friedman. And then it's also, well, then let's talk about correlation and talk about where it's true there. But so let's continue on our path about distinguishing between these different tests, right? So now let me go ahead and just go over to your Pearson correlation. And this is the annoying one, because it's got that linear assumption there, and you kind of have to make that call as to whether it actually is, I want to show this to you.
Yeah, I think I really struggle. I feel like I really struggled determining if it's linear or not.
Yeah, I'll do my best to, give you straightforward, not too crazy examples where it's all over the place for an exam. But, because my goal isn't to trip you up. My goal is to just make sure you understand, basically what we're looking at. So I mean, I think I can kind of see for these classic examples here that these two are linear, this is nonlinear, this is nonlinear, and on top of it, it's non-monotonic, which is bad news if you remember, right? It's going in two directions rather than one direction. So with the Pearson correlation, we're trying to figure out linearity. Let me go on. And if you have nonlinearity, if you have more of but it's monotonic, you can go to the Spearman correlation. And if you remember, the one nice thing about this, so here, I mean, I can see this. This is a monotonic linear. This is a monotonic, but kind of got a curve to it. And this is non-monotonic. So if we have something like this guy, we're sort of out of luck. There's not much we can do with our tools that we currently have in our toolbox. But this guy, we can go ahead and do a Spearman correlation. So that's how you choose between those two. Oh, and then there's the outlier thing, right? Now, right, this was the weird little thing, because they talk about all these possibilities for dealing with outliers, right? And I agree. I mean, you could take the outlier out and run it both ways, right? And that's probably the best way to do it, honestly. Run it with the outlier, run it without the outlier, see if there's a very important difference that's going on there. And if there is, you just kind of go through and you say, well, this would probably be the appropriate interpretation, and I'm guessing that would be without the outlier. But we ran it both ways, and we have to consider all the possibilities. So let me say that a little bit less muffled. If you have an outlier and you're going to go ahead and run the Pearson, Or even if you have an outlier, you're going to run Spearman. Same situation. I would run it with and without the outlier, and then go ahead and see if there is a big difference between the two. And that's an eyeball thing. I mean, there is technically a calculator that would tell you if there's a really important difference in the correlation, but we're not going to go there. Just eyeball thing. Pardon me. Okay. And then we look at normality. Okay. Same way we usually do, the similar way that we usually do. And this case, we kind of skate by with our test for normality. Same idea here, right? We're hoping for values, this is Shapiro-Wilk again, we're hoping for values that are greater than or equal to 0.05. Sorry, let me go back for 1 second. Yeah. So again, this is another situation where you can go ahead and run the Spearman, right, if you don't meet the normality. So linearity, you couldn't go to a Spearman as long as you don't have a non-monotonic data. Normality, if you violate that, you can go to a Spearman. Outlier, a Spearman won't necessarily help that per se. It depends. It actually depends on how the outlier looks as to whether or not it'll help it. So don't fuss about making that judgment call, I think, and instead go ahead and whatever you were going to run it, but run it with and without the outlier. Okay. And I think interpretation for this one isn't too bad. Just don't forget that R squared is a useful thing here, and that's the coefficient of the termination. And that'll tell you the percent of variance accounted for. Okay. And I'm trying to remember, someone actually wrote in with a couple of questions I want to make sure I address, and one of them was about correlation. So let me just see if I can incorporate that question in here. Yeah, the question was about the point by serial correlation, and there was just a few slides on it in the correlation lecture, but basically it's if you have one continuous variable, one dichotomous variable with two levels, right? So you basically treat it as a Pearson. It's basically, there's nothing special. You just, as long as your continuous variable meets the Pearson requirements, you could run it as a point. You can run the point by serial as a Pearson. Now we're not going to run any of those. That was just something we talked about theoretically. Okay, that was just a couple of theory questions, theory type things that we talked about. So that's point by serial. One other, well, I'll see if this question comes up later, or I'll incorporate it in at the end. But that's the basic rundown, I think, of how you tell the difference between the different tests. Let's see if you have some follow-ups on this, or if you have other things you'd like me to talk about. Okay, maybe while you're thinking about that, I'll go ahead and didn't mute myself, did I? No. Okay, I'll go ahead and ask this other question that was asked by a fellow student. Can you please offer some examples of how to identify an interaction or main effect in a factorial analysis, both in a table and on a graph? So I think the best, I want to look at an example with you to do that. So I'm just going to go now. This is, again, we're not actually going to run factorial analyses, but let's just look at something where they've done one, like a two-way ANOVA. That would be one where we have the potential for interaction. And what I want to do is show you how I think the question about table, it might be about like how you look at it in SPSS. So yeah, here we go. Determining whether an interaction effect exists and what you're looking for. Actually, this is a really nice piece in here. It's layered, it's page 12 under two-way ANOVA. What you're looking for is, are your lines going to cross at some point? So if you look at a graph, are your a line graph, and that's how you usually look at these, are your lines going to cross at some point? So all of these, notice how they're all parallel, and notice how all of these, see, even this one isn't crossing yet, but if the line continued, you can see that eventually this would cross this. Same over here. They haven't crossed yet, but they will. That's how you know if you have an interaction. That's the graphic way. That's kind of the way I think is easiest to tell. But in terms of SPSS, if you're curious, your main effects are listed like this: gender, education level, just like you're used to. And when you see gender asterisk education level, when you see two variables together separated by an asterisk, that's your interaction. And then you would just go across the ANOVA table like you would for anything else and see if it looks significant or not. Right, and we're always comparing to whatever our alpha is. We'll assume it's 0.05 in this case. So this interaction is significant. Turns out gender is not significant, educational level is, but this interaction sort of overrides those two. If you have a significant interaction, that suddenly becomes a lot more interesting than the two main effects. Okay, so again, if you have a two-way ANOVA, which is two variables in there plus an interaction, that's how you would interpret that. Okay, so each IV is a main effect, and the interaction again has that asterisk in it. Okay, so that hopefully answers that person's question. Okay, what else can I answer for you or go over or anything?
I feel like it's been really helpful having like the recorded lectures. That's why I don't have as many questions, because like I'm able to watch them back, and like if I have a question, I kind of just refer to them. But the thing I'm thinking about right now is like, since we don't have the homework solutions, like tomorrow, Tuesdays and Wednesdays are like my longest days. I think we have like 12 hours tomorrow, and then I go like straight through until your class on Wednesday. So I just don't know if I'll be
Yeah,
able to see the solutions before the test.
Okay, that's concerning then. Let me think for 1 second.
Yeah, I'm sorry to just like put that on you right now too. I know it's really close to the test, but I just
No,
it's
I
something was
know, and
thinking
I
about.
wanted, that's fine. I appreciate you letting me know. What can we do? I mean, do you want to go through a couple of those like right now in real time?
Yeah, we can do that. I mean, I can always watch the I guess I don't really have time to now before Wednesday. Yeah, that sorry, I'm just thinking out loud.
Yeah, no, that's fine. So yeah. Okay. So you had homeworks on, let's choose one at least to start with, and then we'll kind of just go from there. So you had homeworks on ANOVA, repeated, you know, the ANOVA versus Kruskal-Wallis. You had a homework on repeated measures ANOVA versus the Friedman, and then you had a homework on the correlation. Which one shall we start with?
Was there one more? I'm just going back to the homework list really quick.
Yeah,
There was
it was 5, 6, and 7.
five,
To
six.
my
Oh,
recollection.
okay. Sorry. Yeah, you're right.
Yeah, because we didn't get to simple linear regression yet.
Okay, right. Okay. Yeah, I mean, we could start with whatever you prefer. I'm just opening my homeworks now.
Okay, doesn't really matter. Let's just start with the one-way ANOVA then. And I mean, I already have output for those, so I can kind of walk through the output and walk through the process. So let's do that. Let's see how it goes. Let me just pull up the right thing. Maybe. Oh, okay. 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 So I'm opening SPSS, then I'll share the screen with you. My SPSS license just recently expired, so I got a new one, but this means that I'm now on 27, which is actually has a couple of nice features, but I've avoided them to make sure that I'm as compatible with you guys as possible. But it was kind of cool because they actually offer an effect size now where they hadn't before, right in the regular ANOVA. Okay, so now I want to do a new share of, I'm going to try this and see how it goes. All right. Can you see my output?
Yep.
Okay, perfect. Okay, so the first example was 5.2a, and it had to do with giving nursing home residents a plant, either a bamboo, cactus, or no plant, and then looking at depression levels. And so the first thing we want to do is run our explore. So we do this, we get all this lovely information, including the test of normality, the Shapiro-Wilk right here, which shows that we have violated the Shapiro-Wilk in two cases, in the no plant and the bamboo. So we already know we're going on to a Kruskal-Wallis. But because we like to look at things, we'll continue to do so. We come down here and we see some outliers also for bamboo. I see 3 outliers here. So again, more evidence that we clearly need to do the Kruskal-Wallis here. So we press on to the Kruskal-Wallis. And we get our test statistic, degrees of freedom, and p-value. And remember, there is this extra assumption in Laird about the distribution here within the Kruskal-Wallis, and I was saying you don't have to worry about that. And I believe the same is true for the Friedman, that they want you to look at that. And I have the same opinion there. You don't need to look at it. And again, for this class, I'll just put that little emphasis in there. But yeah, you don't need to worry about that piece. So we didn't go over that. So we have our graph there, and we even have our pairwise comparison, which is telling us bamboo to no plant. Yes, that is significant. Bamboo to cactus is significant. No plant to cactus is not significant. Okay. And here I do recommend using the adjusted sig values because they are nice and Bonferroni corrected for you. Okay. So adjusted sig over here. And then we just get this, we get this other lovely stuff, but, oh, and then the one other thing is we would like to report medians. So you have a choice. I went ahead and ran this because Laird says, you know, this is a way to get medians, and you go to compare means, and then you can just take out the other stuff, leave your count, leave your median, and you'll get medians. Alternatively, if you don't like running extra stuff, you could go back up to your descriptives, and you've got a median here for no plant, you've got a median for bamboo, and you've got a median for cactus. So, you know, your call either way. Okay, so that's the first one. And then I want to switch over. Yeah. Let me go. You're still seeing my output, right? At this point.
I see Laird now.
You do? Oh, okay, I must have did it right then. Perfect. Wow, okay, good. That's not what I wanted. I wanted the, I'm trying to think of a way to like make the right part not as bad. So the for this test, for the Kruskal-Wallis H test, if you go into reporting and you go under APA, I guess it doesn't matter whether you use the top one or bottom one as much, but I like the top one. I think it's a neat way to write it up. So I would say Kruskal-Wallis. I would first say that we violated the assumption of normality, and we violated the assumption of outliers. Okay, and we saw how we did that. And then therefore the decision to run the Kruskal-Wallis H test was made. And then we can start right in. That it was used to, it was conducted to determine if there were differences in depression scores between groups that differed in receiving no plant, bamboo plant, or a cactus plant. Now this is the line that we don't really need. The distributions of CWWS scores are similar to specified visual inspection of a box plot. That's that distribution thing I said we're not going to worry about. Then we can say median CWW or median depression scores were statistically significantly different between the different levels of plant group, and we would report the statistic, the p-value, and then we can talk about the subsequent pairwise comparisons. And it even says with a Bonferroni correction, so, and the adjusted p-values are presented. And then we go through and we would say this post hoc revealed statistically significant differences in depression scores between the, and I believe it was, I'd have to look back, which groups were different from each other. It was between bamboo and no plant and bamboo and cactus. Okay. So that's how I would write that one up. I know that's not exact, but hopefully it's close enough to give you the sense. Also, I don't know if I've explicitly said this before, but I'm just going to say it again in case I haven't. But you know, you should absolutely feel free to use the write up here and insert your own information, as opposed to trying to make it your own or anything like that. So definitely feel free to do that. Okay, So we went through the Kruskal-Wallis. Let's go through one that's an actual ANOVA then, which I believe is 52B. So I'm trying to see. Good, I am sharing my screen, so that's good. Okay, so let me go over here to this, to 52B. And with this one, we'll see a very similar situation in terms of the setup, right? We still have got our plants and we've still got our depression scale that we're looking at. So once again, we look down to the Shapiro-Wilk, except this time we meet all the criteria, right? All of them are above 0.05. We go down to the to look for outliers in the box plots. Once again, we're perfect. Met all the criteria. So then we come down, we can look at some descriptives here. We're going to see what these means are, these standard deviations. I just like to look at that because I think it's helpful. Now I'm going to look at this Levine statistic. And this is homogeneity of variance, right? I'm testing for that. Now, again, my sig is higher than 0.05, so that's good news. That means I did pass the test for homogeneity of variance, which means I'm going to use this standard ANOVA. And here's my sig value, which is not significant. And I'm really done here because if that's not significant, I really don't need to look at my Tukey post hoc. I think this might have been the one, or I can't remember if it was this or repeated measures, where we had this weird situation where we had a mismatch between the SIG and the ANOVA and the post hoc. I think it was where we had a significant value in the ANOVA, but we did not have any significant Tukey or post hoc tests, I should say. So that was kind of wacky, and that can occasionally happen, but it's really rare. But if you don't have a SIG here, it is safe to say I don't need to move on. But I'm going to move on because, you know, for example's sake. So then I would be using the Tukey over here. And again, I'd look across to see which groups I'm comparing. And if you've got 3 groups, it's always row 1, row 2, row 4 you want to look at. Okay. Now let's pretend, since we're, you know, just doing this to kind of go through it, let's pretend that this wasn't 0.333 but was 0.003. Then it would be significant, right? So then we wouldn't use this ANOVA, we'd use this Welch ANOVA, and we would use this SIG value, the 0.218. Now, again, since we're pretending, let's keep pretending and pretend this wasn't 0.218, but 0.002. And therefore, we would go on to look at the Games-Howell multiple comparisons. It's the same setup, really. You just look at rows 1, row 2, and row 4. Okay. Yeah, that's pretty much. Oh, and then, yeah, this is the thing that they've improved in the current version, but if you want to actually also have your eta squared to report, which is very nice, and there is a hand calculated one, but I think why do that if you can just quickly get one out of SPSS? You run the Uni ANOVA, and you just select to report the effect sizes, and then the only thing we care about down here is this partial eta squared. Okay. So, let's talk about this one in terms of a write-up. And then I'm going to check in with you guys and see if this is being helpful or not. But let me get through this one first. Reporting. So I'm going to the reporting area. And then I guess the idea is, try to find the one that most matches your situation. So in this case, it's the one-way ANOVA not statistically significant and variances were equal. Like that's where we were, because we didn't have a significant ANOVA and we did have homogeneity variance because we didn't have that be a problem. So then we'd wind up down here. With a one-way ANOVA was conducted to determine if the ability to cope with, to determine if depression was different amongst different groups given plants in a nursing home residency, or nursing home residents given plants. And then we have our groups once again of bamboo, cactus, and no plant. In this case, we can say there were no outliers as assessed by box plot, and the data was normally distributed for each group as assessed by the Shapiro-Wilk test. And there was homogeneity of variance as assessed by Levine's homogeneity of variances, and that was, I believe, P equals 0.333. And then, yeah, this you could do. This is a bit debatable. They're sort of saying, here's how they increased from this group to that group, but the differences was not significant. I think if you'd like to cut this a little shorter, you could just go on and say there were no significant differences between the groups. And I would still report the mean and SD for your 3 different groups, but I wouldn't, I don't think you have to report this one increased a little bit, but it wasn't significant. If it wasn't significant, it wasn't significant. I wouldn't get into that. So I don't know, that's just a minor point. It doesn't matter if you want to do it that way, exactly following Laird, it's fine. I'm just saying if you don't want to note that, you don't have to. And here's our F. Now, since we were playing around a little bit, if we don't have the one-way ANOVA was not statistically significant again, but the variances were unequal, and that's when we pretended that our homogeneity of variance was not equal, then we would just be reporting our Levine's test of homogeneity of variance, and then same basic idea, except we'd say Welch's F down here. And yeah, and they actually have all 4 listed out here. This one is the one-way ANOVA was statistically significant. Variances were equal and a post hoc test was carried out. So this just talks about the post hocs a little bit more. And this one, post hoc test was carried out and the variances were unequal. So this is where you're doing the Welch again. And you're also talking about the Games-Howell, right? Games-Howell post hoc test. Okay. So I'm trying to go through and show you like as many different possibilities at the same time. All right. So, how do I phrase this? Would you like me? I mean, we can close down shop now. We could steer to another couple of questions, or I can go on and do the same thing with the repeated measures ANOVA one.
Well, I have to go at 7 anyway, so I
Okay.
don't know if it's enough time for me
Go
to
through the
watch you
repeated
run through. Yeah,
Yeah, okay, that's
that was
fine.
helpful though for the other one.
Okay, all right. Yeah. Okay. What I will I'm just trying to think out loud for 1 second. What might be would it be helpful if I recorded myself going through the same thing for repeated measures ANOVA and posted it tonight? or is that already just beyond what you can look at? Yes, for one. If it's helpful for one, I'm going to do it.
Will you still post the solutions? 'Cause I know like
Yeah, sure.
okay.
Yeah, no, that's no problem. I just thought it might be helpful to get you this quicker. I'm just trying to think of like the speediest way to get it to you.
Thank you.
Yeah.
Good measures. Are you going to be using an example for the homework?
Say that one more time. I'm sorry.
For the repeated measures, will you be using an example from the homework you said? Or
Yeah, for the recording.
yes.
Yeah. I was just going to keep recording and go through like a repeated measures ANOVA one. Yeah, I'll do a repeated measures ANOVA one. I can do a Friedman one too, but I think that's probably, you know, less
Yeah,
critical.
I was asking, exercise.
What were you asking? I'm sorry. I think I missed it.
No, yeah, that's what I was asking. But I was wondering if you could do exercise 02B for chat, like for that homework assignment for repeated measures, because I know
Oh, sure.
like I didn't do something right. But
Okay. Yeah. 6-2B or whatever 2B on that. Yeah. You got it. Yep. That will be the one I do.
Thank you.
No problem. And then like I said, I'll still get you write-ups so that you have that. Okay. So any other questions you would like to ask now?
I think that's all from me, but this was really helpful. I really appreciate you doing this.
Yeah, sure. No problem. Yep. So, okay. If anyone else has any other questions, let me know. If you're done, that's fine too. And stay tuned for the other pieces. I'll get that to you. It's what I'm going to be working on this evening. So, I'll just pass stuff to you as I get it.
Thank you so much.
Yep, you're welcome.
Thank you.
Okay, yeah, you have a good one.